Okay, so now we're going to do exercise 6.3. So the first thing we're going to do is make this into a free body diagram. So I'm only going to draw the forces that I'm interested in, although probably I should have done a space diagram to work out angles. So this angle from here to here is 70. So if I do a right angle triangle in my head, we got 70 plus 90, so that's 160. So I'll make that a 20 degrees here. So 20 degrees going from there to there. And the other one is, if we make that into a right angle triangle, give me a bit more space to do this. So that angle at the top is 40 plus 90, that's 130. Take away, so we've got 180, take away 130, so I'll make that 50. Okay, let's do a check on that. 70 plus 90 plus 20 is 180, yeah. 50 plus 40 plus 90, 180, okay, I haven't made any stupid mistakes. Right, so there's my diagram. Should have done a bit bigger, never mind. We've got mg acting down here. M equals 12 kilograms. So the force, we will call this weight force. So weight equals mg, like that. So the weight is going to be 12. It's going to be 12 times 9.81. So in stress and dynamics, we always take acceleration of gravity to be 9.81, unless we're making an crude approximation somehow. Maybe you might take it to 10, but otherwise for your calculations, 9.81 will do. So 12 times 9.81. So we have a total force of 117.72. Notice I'm not going hardcore here, I'm using angles and things. So this equals 117.72 newtons. Alright, so the first thing I do is I resolve forces in the x direction. That's a good direction to resolve forces in, because we've got two unknowns, and if we resolve in the x direction and one known, we will ignore the known. When we resolve in the y direction, we will have two unknowns and one known. So by going in the x direction first, we're reducing the number of terms that we're looking at. So resolve in x direction, it's not moving anywhere, so this time I'm going to say when I add up all my forces, they should equal to 0. So here, carry on my diagram. I really should have done it bigger. Let's find the complementary angles there. So here, and they should be the original angles, so that would be 40 there and 70 there. Okay, so when we add up our forces and we're going in the x direction, we're going to label and point out that that should be positive. So the first one is this force here, which we'll call tension 1 and tension 2. So tension 1 has to swing through 70, and then it'd be pointing in the negative direction of where I've decided what's going to be positive. So the first one's going to be minus T1 times cos 70. The second force, we swing through 40 to get to the horizontal, and then it'll be in a positive direction, so plus T2, which will be cos 40 equals 0. So therefore we can say that I'll probably get rid of T2, so therefore T2 equals T1 times cos 70 divided by cos 40. So see what I've done there? I've taken this over to the right hand side and then I divided through by cos 40, so I've ended up with a term like that, and I'll call that equation 1. Okay, now let's resolve forces in the y direction. I wouldn't write your solutions out so cramped as I am. So we've got adding up the forces in the y, and they are going to be, when we add them up, going to equal 0. Things not moving. So what we got this time? So if this is positive, now we can see that to swing through to the positive vertical direction, we need to swing through 20 degrees. So we've got T1 times by cos 20. Notice I'm just using coses all the time. Swing through 50 degrees here to get that point into vertical. So plus T2 cos 50. And the final force is this one here pointing in a negative direction, so minus 117.72, and that all equals 0. Okay, so we're going to use equation 1 and substitute this into this equation 2 and get rid of this T2 here. So when we do that, 1 substitute into 2, therefore we have T1 cos 20 plus T1 times by, notice we've got lots of coses here, so we've got cos 70 times by cos 50 divided by cos 40. Okay, right, so that's that substituted in and multiplied it by the cos 50 there. This known value I'll take over to the right hand side, so it equals 117.72. Right, let's factor these terms here. So we're going to have bring this and this together, so we've got T1 equals cos 20 plus cos 70 times by cos 50 divided by cos 40. Okay, kind of looks like cos 40, and that equals 117.72. So I'm going to work all this out on my calculator, and then I'm going to divide it by that number there and find out what T1 is. So T1 equals, I will write out the algebra, I'm running out of space and I'm trying to keep it on this page. So I've got my 117.72, and we're going to divide it. So we use lots of brackets to get this expression in. So we have got to do, open a bracket, cos 20, now close that bracket, plus, don't need brackets here, so we've got cos 70, close that bracket, times it by cos 50, close that bracket, divide it by cos 40, close that bracket, and then we need to close the bracket at the end, so close it again. Right, so when we've done all that, we end up with 966. So therefore we have, if we round this up as 96 newtons. Okay, so we'll use this number and we're going to substitute this more accurate result into this equation here to find what T2 is. So come back to substitute into equation 1, therefore, and we end up with T2 equals 95.966 times by cos 70 divided by cos 40 equals, so just managed to squeeze it in there. So I'm going to times that by the previous answer by cos 70, divide it by cos 40, and what do we get? Right, so we're looking for final answer here, so we could write that out, but so we'll just go for the free sig fig. So 42, as we're already at final answer, 42, the meaning of life. So how am I going to round this up to free sig fig? Well, 4 fig is 4, so we ignore that, so it's going to become 0.8. Okay, just managed to squeeze it onto that page.